right, here we go. We're going. All right, simplifying square roots. A square root must always, 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 always be simplified. Always. It is unacceptable to write down an answer that is unsimplified. So we are going to be simplifying square roots pretty much the rest of the year, so it's important we learn this. So, the square root of 245. This is not simplified. And the reason is, if you can divide your inside of your square root by any of your perfect squares, then it's not considered to be simplified. So there is a number up here in bold, or on your little cheat sheet, which is the last page of the packet, that you can divide 245 by. Now 245 is a pretty large number, and we can't divide it by any number bigger than it, so I'm just going to put a box around all of my bolded perfect squares that are less than 245. There's a lot of them to check. 225 all the way down to 4. So we need to see what can we divide 245 by. Now, there's an easy way to automatically eliminate a bunch. If you take 245 and divide it by 2, this lets us eliminate a bunch. 122 about. So I can cross off boxes all the way down to 122 about. Okay, just by dividing it by 2. So I've narrowed down to 121 and down. Again, these bolded numbers are my perfect squares. Okay, now this is the tedious part. I know, I wish there was a perfect way and you just could look up here and know immediately what it's divided by, but you just have to do some testing. You know it? Shh, don't spoil it. Okay, so we just got to test. 245. You always type in your number underneath first, and let's start dividing. Can you divide 245 by 121? Maybe you know, maybe you don't, but we can always check. You type it in, click enter. You get a decimal, and 2.02, that's a decimal, gross, cross it out, does not work. Check the next one. 245 divided by 100. Click enter. Decimal, no good, it can't be 100. Keep going down your list. Divide by 81. Decimal, no good. Again, this is the worst part. It's tedious, especially for big numbers. 245. My next one is 64. Maybe, fingers crossed. No. Does not work. 245 divided by 49. What happens? We get a nice whole number. 245 can be divided by the perfect square, 49. We want to split up our square roots into a perfect square times another number. 245 we would rewrite split into 49 times 5, exactly. 49 times 5. Again, there's a lot of things you can divide 245 by, but we want to divide by a perfect square because we know the square root of 49. Okay? 49 and 5 get into an argument, they move out and they get their own apartments. I know it is. But students remember corny things more than boring math things. We know the square root of 49. It's in our chart. It's on that sheet on the back of your packet. Square root of 49 is 7. Why write the square root of 49 when it's just a normal naked 7? Square root of 5, is that on our list? I don't see a 5, square root of 5, so attach it to the end. Simplify. Done. If you got number 1 right on your quiz and only number 1 right, hey, you passed. That's a D. We're all better than that, but at least that's a pass. Your second problem will look a lot like the first one. What's the only difference between these two, really? It has a negative. It has a number on the outside. And although it looks frightening, it looks way different, it's pretty much exactly the same. We're going to ignore the negative 2. Just for right now, and we're going to just do the same thing. We need to figure out what perfect square, again, when I'm saying perfect square, I'm talking about the bolded bottom row numbers. We need to figure out which perfect square can I divide 320 by. And again, you can't divide a number by a number that's any bigger than it. Okay, so 320. The first one smaller than 320 is 289. So these are all of the numbers we have to check. That's a lot of numbers. Okay? You can just start at 289 and start checking, or you can at least get rid of some of them just by dividing by 2. If I divide by 2, I get 160, and I know it has to be less than 160. So at least now I can cross out all of my boxes bigger than 160. And at least now there's a little less to check, but there's still a good amount to check. Now, again, I wish we could just look and know. But our calculator does a great job of helping us find it if we just have the patience to type it in. Start with typing in your number under the square root always, and start dividing. Divide it by 144. Doesn't work. Okay, it can't be 144. Try 121. Still doesn't work. Okay? And we could sit here and keep going down our list, and the first one that ends up working is 64. 64 is the biggest perfect square we can divide 320 by. Now, you can also divide 320 by 16, which is on the list, and you can also divide it by 4. Both of those are perfect squares. But for the least amount of work, you want to find the biggest. That's why we always start biggest and work our way down. Okay, so when I split this up, I'm going to not write 320, but instead I'll write 64 times 5. Okay, because 64 times 5 is 320. Now that negative 2 doesn't go anywhere, so just bring them down for the ride. Again, a lot of relationship problems today, so we're about to break up 64 and 5. The reason we chose 64 and not some other number is because when I look up here, I go, oh, I know the square root of 64. It's 8. This 64 is just 8. Bring down your negative 2. 64 becomes 8. And we got the square root of 5 still chilling, which isn't in our list, so we can't do anything to that. Now, all of these were being multiplied together, and they're still all being multiplied together. Now, I'm allowed to multiply negative 2 and 8 together. They're just normal numbers. Negative 2 times 8 gives me negative 16. And the square root of 5, again, I can't simplify that. My smallest perfect square is 4, and you can't divide 5 by 4, so it just gets attached to the end and is chilling. Negative 16 square root of 5, that is a perfect answer. Right now, you have a C. That's a C. Almost a B. Okay, that's simplifying square roots. It's always the same. All I can do is change the number under the square root and the number in front, otherwise everything is the same. The second thing we learned this topic is what's called the square root method. Now, 2 weeks ago, we learned to factor and solve quadratics with that X method, which is long and tedious and a lot of hard work. In special case scenarios, sometimes quadratics are missing the x, just the normal x without an exponent. And when it is, you get to take a big shortcut. If you look at 3 and 4, both 3 and 4 only have x squareds. They don't have any x's. Alright, here we go. Waterfall time. 4, just like we're doing now. They're just like this. I looked at the test while I made these 4. Did everything the same except the numbers are slightly changed. Mr. Tokar. What room are you in? Okay. They need the security office in 314. I don't know why they called me. Okay. Squiggly down the equal sign. We get to solve this old school way. So wherever you were 2 years ago, sitting at home, learning online, or in class, who knows, you were in Algebra 1, and you were solving problems like this. Okay, we need x squared by itself. What needs to be moved? The 12. It's a positive 12, so how are we going to move it? The opposite, minus 12 on both sides. 12 minus 12 is 0. It's gone. That's why we chose to subtract 12. Bring everything down. Negative 60 minus 12, negative 72. Okay, we're getting closer. Again, our problem is done when we know what x equals. We don't really care what negative 2x squared equals. So the next number that's got to go, take a hike, is the negative 2. When two things are touching each other in math, it means multiplication. The opposite of negative 2 times x squared would be to divide negative 2 on both sides. That gets rid of those pesky negative 2 in front of the x squared. Sadly.
You said you can't?
Can't. But you can look it over and study it, and you'll be good to go.
What happened to the two part we have?
Negative 72 divided by negative 2 is 36. And yay, this is when you're like, oh, thank gosh. 36, that shouts out perfect square. It's in our list. But we don't care what x squared equals. We want just x. How do I get rid of a squared? Square root both sides. Square root of x squared is x. And now remember from yesterday or a couple last week, what is the square root of 36? Positive or negative 6. We have that symbol, plus or minus, which means positive or negative 6. Oh, because it was a negative 72 divided by a negative 2, so we gave us a positive number. Good question. Okay, 1 to go. Again, this right here, you're at a B. B. That's a B on the quiz. This last one is how you get the A. Waterfall down the equal sign. This is the A. Little trickier because we have variables on both sides. We got numbers on both sides. Our x squareds have numbers in front. There's a little more work to do here, but again, our goal is exactly the same as 3. X squared has to be by itself on one side. Since there are x squareds on both sides, you have a big choice to make. You can either move them to the left side or move them to the right side. It does not matter what you choose, but you need to choose a side. I like to choose the left side in this case because the left x squared is larger than the right side. And I won't have to deal with any pesky negatives. So this 2x squared, how's it moving to the left? Subtracting, yes. Subtract 2x squared. Now it's important you do write this underneath the 3x squared because those are like terms. 3x squareds minus 2x squareds is just 1x squared. Drop everything. To get rid of the minus 8, we do our opposite. Add 8. And x squared equals 12. And now you look at your answer and you can kind of look into the future and you're a little sad. Because look at 12. Is that a perfect square? It's not. So you know there's a little more work coming than before, but it's not going to be terrible. Square root both sides. X equals. Is my answer going to be Square root of 12, I'm done, yay? Because what can you do with the square root of 12? You can simplify by taking out a perfect square of 4. So I should split square root of 12 up into 4 times 3. 4 times 3. Okay? I'm going to extend the page a little. Not that much. Okay? Again, yet another tragedy. Breakup story of the century. 4 and 3 no longer together. The square root of 4, we know, is at plus or minus 2. Yeah? You know what I mean? Like, that's like taking your 2 kids to the grocery store and you just leave one behind. You know what I mean? You can't just leave one of your solutions behind. Plus or minus 2, square root 3. Okay, 4 became plus or minus 2, because all square roots have 2 solutions, positive and negative. And bring down the square root of 3, can't be simplified. And there you have an A on your quiz for Wednesday. That's an A, A++.